I have built the Order Execution Engine, a system that processes market orders with DEX routing and real-time WebSocket updates. I will first demonstrate the POC implementation, then show the real Devnet execution. So this is the Postman collection with few health checkpoint. This is the Post API endpoint for creating the order, which further get updated to the WebSocket protocol for real-time upgrades. So let me first demonstrate you this Post API endpoint. Let me spin up the server side by. This is the request body. Pair is Solana USDC. Side can be altered between buy and sell. Amount is 0.02, slippage is 40 basis point. So let me make a post request to this API endpoint. So it's been executed. So this is the post request. I have been getting order ID in the response, and these are the worker logs. So the first status here coming is it is in the routing stage. So what happens in the routing stage is the key feature of DEX routing. In this, the system fetches codes from Raydium and Meteora. So Raydium it fetches $100.44 and Meteora it fetches $100.30. So for the buy orders, since we are placing a buy order, so it selects the lower price. So lower one is corresponding to Meteora, so it selects this Meteora. And furthermore, it moves on to its life cycle, carry forward in the next stage, building, submitted, then confirm. Once it gets confirmed, it shows the transaction hash, which is this, and this is our order for reference to worker corresponding to job number 56. So this API endpoint also get upgraded to the WebSocket protocol. So this is that, and this order ID get automatically updated, ending with PH8, ending with PH8. Let me connect through this WebSocket connection, and the sequence of events are emitted. So the first event is getting properly connected and subscribed for order update, followed by the next it shows the status as pending. Status is pending. Furthermore, it shows the status routing. Next, it shows the status as building. After building, it shows status as submitted. After submitted, it shows status as confirmed. In confirmed, it gives us the data, transaction hash, shows an DEX as Meteora, and the executed price at which it has been executed. Next, I will demonstrate you with the multiple orders. I will be submitting 5 orders simultaneously, and let's check how it's been able to handle by the queue system. Since the queue system worker can handle concurrency of 10, and the rate would be 10 jobs per second as logged by the worker. Let me demonstrate you that. Let me go to the create order, and I will simultaneously make buy request. This is first, this is second request, this is third, this is fourth, and this is fifth request. All the logs are been properly been displayed. So here you can check all the status of the life cycle varying from routing, building, submitting, confirming are shown properly. In this case, it pages the live code of Raydium 101.48 here 100.31. So the minimum it would shows Meteora because we are buying. In this previous execution of buy order, it checks the live code, and corresponding to it minimum would be of Raydium, which is 101.05, which is the cheaper from Meteora. So this is all different completion times, which shows all the parallel execution in the system. Let me show you the real DevNet execution. I am switching to real DevNet execution. Just change the parameter to true here. That would enable real DEX execution mode. Let me first spin up my server. Similarly, I will make the create order. Let me make the API endpoint request for it. It got 202 accepted as well as order ID in response. Let's check the log one by one. So this is fetching code from transaction devnet radium.io. Let us go through this one by one. Currently, it's fetching the codes corresponding to Solana and Raydium. For both the Raydium as well as the Meteora, it is discovering the pole, and corresponding to Raydium, it is also discovering the code. So this is the API response for Meteora. Actually, we didn't find any pole that is being common between both the DEX. For Raydium, we have find out the code with the pool, that is Solana and Ray, with the rate 77.93. And this is the router, DEX routing, where the Raydium and Meteora are being compared. And we have been choosing the Raydium because it is cheaper. And furthermore, the order is been updated with the lifecycle building, then submitted. So this is the swap code that is happening, and we have got the URL. So this is the response that we got corresponding to it. Furthermore, we received the code, and then the transaction has been built at radium.io/transaction.swapbasin. And this is the Raydium logs corresponding to the transaction one that is confirmed with this transaction X at price 77.93. And on the Raydium, we can see it on the Explorer, Solana Explorer. Let me open this, where you will see more detail regarding it. So I'm on the Solana Explorer in the DevNet. So corresponding to this transaction, this was the signature that was logged. This is the details, and 0.02 transaction has been logged here corresponding to this address. this is order is confirmed with the transaction as I am getting as this. That's all implementation of the real DevNet. The issue encountered during this I found challenging the Meteora's DevNet because that doesn't have pools of the test pair that are compatible with Raydium. They have over 10,000 pools, but none of match the use cases I was trying with. Some Raydium routes are also unavailable on DevNet. They were asking to test on mainnet only. So I built this fallback mechanism so that it would use mock in case of Meteora. And the system automatically switches the mock code if it doesn't find the live codes. So that's all the real DevNet implementation. So in summary, Raydium integration is fully functional with real API call live DevNet execution. Meteora integration includes pool discovery and swap execution logic. But due to unavailable pool for test pair, it fallback to mock pricing. The router handles real and fallback data seamlessly while always selecting the base price. The system demonstrates production grade structure and it handles gracefully and it has very robust execution flow.